My question is, where will Matt end up if his start is at the origin? And how long does his journey take him? Suggestions on how to do this? Bigger voice. Pythagoras, what will that give me? But what will it give me? We know how to do it because we're assuming this is a right angle. So it's going to give me the resultant velocity vector or the resultant magnitude? It's going to give me the magnitude of his velocity. The magnitude of his velocity is really lovely. It's just Pythagoras' theorem. A second. It's a magnitude because it has told me absolutely nothing about his direction. Agreed? How would I find out his direction? I don't have a theta. Where would you like to put theta?
At the beginning of the beginning.
Here?
Sorry, yeah.
If we're going to introduce the theta, we need to introduce the theta. So if I do tan theta, I'm going to get opposite over adjacent. Pull out your calculators. Give me that to the nearest degree.
37.
What is it?
37.
37 degrees. All right. So I now know that Matt is travelling on a bearing because it's from north of 37 degrees true north at 5 meters per second. And I have not answered this question. What do I need to do to answer the question? The question was, where does he end up and how long did it take him? Now, like all problems, when we get stuck, we go used, used, found, found, sitting here doing nothing. Why did I tell you how far the river was across? Does it matter how far the river is across? It does. Of course it matters how far the river is across, otherwise you're like, oh my God, I'm guessing he's not going to be maintaining 4 meters per second. How are we going to use this? To find the time. Can anyone remember way back how are speed and distance and time related? Speed equals distance over time. I want time, so that's equal to distance divided by speed. I've got all of these. What's my distance? 20. What's my speed? And which speed do we do it at? 5 meters per second. Why 5 meters per second? It is his velocity, but did he travel 20 meters? In which component did he travel 20 meters? His vertical component. Yes? So which speed's going up here? Notice I'm talking speed because I'm making it in the same direction. So my direction has no bearing on this. What do I get out? 5 what? Seconds. I know it was seconds because that comes from here. So I've answered B, haven't I? So that's the answer to B. His journey took 5 seconds. But I haven't answered A. I do, however, know his vertical component. If I was going to give this a coordinate, what's the vertical coordinate of his endpoint? 20. If he didn't make it 20, he's in strife. If he made it more than 20, he's equally in strife. Which bit am I missing? Horizontal component? Did he travel 5 seconds in the horizontal as well? He did, didn't he? Because he can't travel shorter in one direction than the other direction. So horizontally, how far did he travel? Anyone? 3 times 5, which is? So, Where will Matt end up if his start is taken at the origin? Where will he end up? You can give it to me as a coordinate. I'm happy with that. Which direction's which? Agreed? Or 25 meters at 037 degrees true. This is his straight line, magnitude, direction. This is his component form, which gives me also magnitude and direction. How did I get 25? Because I've just pulled it out of the air. It is 5-second journey at 5 meters per second. You could have answered this question either of these ways. Are we happy with that one? Now Matt's like, that's great, but actually I needed to end up there. What should he have done to end up directly opposite where he started? He should have pointed his boat this way. So part C to this question is, in what direction should he have pointed his boat to end up directly opposite him? Part C, I'll write it up. Everyone happy if I remove the initial question? In what direction should he have pointed his boat to end up directly across from his starting point? In what direction? All right, I'm going to give you 30 seconds. Hint, you need to draw another diagram. Who wants to tell me what their diagram looks like? I'm going to start at O. I've drawn the final vector. Where are my components that end up on this final vector? Who wants to have a go? I've seen a lot of correct diagrams, so there should be a lot of answers. What's something we know that hasn't changed?
The speed of the river.
The speed of the river, and it's acting in that direction. Do you agree? And it's got to end here. Do you agree? So we've got this, and it's what? 3 meters per second. Good. What have I got now? I've got to join these up. Do you agree? What's this one? 4 meters per second. That's him desperately rowing against the current. You can imagine it. He's like, imagine being, oh, you guys didn't get year 11 camp. I'm so sorry. But when you're in camp and they make you row up the icy river and you really don't want to fall in. Which angle am I trying to find? Good, nice, Aditya. We're trying to find this angle. How do we find it? Sine. What's my answer?
49.
Let's say 49 degrees to the nearest degree. And what's that as a bearing, just so that we practice our bearings?
If you run
What is it? 319? 311. That's much better. I can't end with a 9.
Oh, yeah.
That's why I was confused. Hang on, there's no 8s at the end here. Are we okay with this? So the trick with these questions is this diagram. Once you've got the diagram, you can resolve it into vector components. You can play with everything that we have.
A little, okay, but basically, you know how I think like a couple
Boys, shh.
months ago you told us that like when you're writing theta equals, like first you have to write it to like all the decimal places, and then like, so if I don't do that and I just write that, will I get a mark?
Okay, rather than concentrate on will I get a mark or won't I get a mark, think about what the question's asking and how many marks are addressed to that. If I asked you this question, chances are there's 1, maybe 2 marks. If it's 2, I would imagine it's 1 for this and 1 for this. In which case, if I'm taking off a mark for you not writing a line of working, that's not really fair. Okay? If I've given you 2 marks and the whole point is to show all of those lines of working like it's a show question, then yes, you might lose a mark. So you have to look at what the marks are worth and is this worth a mark within the context of this question? All right, I would imagine this is maybe a 1, like I said, possibly 2 if we're being generous.